All right, so we are to our last chapter of the school year, which is on probability. And so we're going to start looking today at finding the probability of rolling a die, picking a card, spinning a spinner. That's a simple event because only one of those things is happening. So probability of simple events, the probability of something is the chance that some event occurs. For example, the probability of rolling a 4 when you roll a die. The probability of picking a 2 of clubs whenever you're picking a card. The probability of spinning a spinner and landing on blue. Those are all probabilities, and we can find a number that represents the probability of that event happening. Once again, a simple event is one outcome or a collection of outcomes, like spinning a blue, spinning red, spinning yellow, spinning green. Those are 4 different outcomes. A spinner that has those 4 colors would be called a simple event. And so we're going to be seeing those simple events today and then finding the probability of something happening. And then another important thing is if something is random. So we want probability. Our goal is to have probability be random. That only happens if each outcome is equally likely to occur. We'll talk about a little later some times where each outcome is not equally likely to occur. So that means it would not be random. But if everything has the same chance of happening, that is a random event. So one example would be if you have a die. There are 6 sides to that die. Each one of those sides has the same opportunity of landing on it as the other. And so there is a 1 in 6 chance you land on each number. They're all the same probability, which means they are random. It is random as to which number you're going to land on when you roll a die. Okay, so a little bit more about probability. The probability of an event happening is a ratio. We write it as a fraction, a percent, or a decimal. A lot of times we will write it as a fraction, but sometimes you're gonna be asked to write it as a percent or as a decimal. And so you need to make sure we know how to write all of those. But this the probability ratio, number of favorable outcomes over the number of possible outcomes. And favorable outcomes are when the event occurs. And so the event that we want to have happen, the maybe rolling a 3 or spinning a blue, that's what we want to happen. So favorable outcomes, when that event occurs, what we want to happen. So that is a favorable event. So how many sides or how many wedges of the spinner have a blue out of how many possible options are there on that spinner? That's an example. Okay. So this is an important, a very important slide. The probability of an event occurring is always between 0 and 1. So if you look at this chart, the probability of you landing on the probability of 0, that means it is impossible. Okay. And then on the other side, if it is 1 or 100%, then it is certain. So if the probability is 0, that would be an example of the probability being 0 is rolling a 7 on a 6-sided die. That will never happen because 6 sides only has 1 through 6 on it. So you will never roll a 7. That is impossible. Something that is certain is rolling a 1 through 6 on a 6-sided die. You will always land on 1 through 6 or flipping heads or tails on a coin. There's only 2 sides to a coin. It's 100% that you're going to land on one of those, heads or tails. In between 0 and 1, then we have most of the probabilities that we're going to be dealing with. Straight down the middle, 50%, that is, it's not likely, it's not unlikely. I would say anytime you're answering a question and you have something that is between 45 and 55%, So if you have something between 45 and 55%, that is about in the middle. That's equally as likely as it is not likely to happen. Anything that's closer to 75% is likely. So if it's over 50%, it's probably going to happen. It is very likely. If it's less than about 45%, it is unlikely. So one thing that's important to note is if you have a probability, and let's say it is 0.0001, that is not impossible. That is still unlikely. Because if the probability is 0.0001, is there still a chance that it could happen? Yes, there is. Is it probably going to happen? No, it's unlikely to happen. Same thing as if you had a 99.999% chance. That is not certain. That is just likely. Because there is still a chance that it does not happen. So it's only impossible if it's 0%. And it's only certain if it's 100%. Anything else in between there is either unlikely, likely, or just right in the middle. Okay, so think about some things that we see every day that deals with percents. That would be the weather. Okay, so think about if you're talking about the weather, the chance that it rains. If it's a 30% chance of rain, are you probably going to take an umbrella with you? I would say probably not. If there's an 80% chance, it's probably going to rain. Okay. If there's a 0% chance, it's not going to rain. Okay. So the closer it is to 0, the more unlikely it is. 50%, it could happen. It could not happen. And then closer to 100%, it's probably going to happen. But it's only certain if it's at 100%. Okay. So, that is looking at likely, unlikely, the chances of something happening. Very important that we understand that because we're going to be asked some questions about that. So let's look at our first example. There are 6 equally likely outcomes if a die with sides labeled 1 through 6 is rolled. So what this means, this P6, that is the probability of landing on a 6. Okay, so the probability of landing on a 6 is P parentheses 6. So anytime we're writing the probability, we're going to write P parentheses whatever it is that that we're looking for. Okay, so the probability of landing on 6. The question is, how many sides are there that have a 6 on them? That would just be one side. Okay, out of how many total sides will be 6. So 1 out of 6, 1 over 6. That is the probability of landing on 6. If you have to turn that to a decimal, you would just do 1 divided by 6, and it would be 0.16 repeating. And then if you need to change that to a percent, it would be 16.6%. Most of the time, unless I tell you otherwise, we can just write a probability as a fraction. That's probably the easiest one. Okay, the probability of rolling a 2, 3, or a 4. Anytime you see the word or, you want to add the probabilities. So what this means is that we're finding the probability of landing on 2 plus the probability of rolling a 3 plus the probability of rolling a 4. Well, the probability of rolling a 2 is 1 out of 6 plus the probability of rolling a 3 is also 1 out of 6. Plus the probability of rolling a 4 is 1 out of 6. Okay, so that's the probabilities. We add those up, we get 3 out of 6. And 3 out of 6 simplifies to give us 1/2. So the probability of rolling a 2, a 3, or a 4 is 1/2. Because think about it, 3 of those 6 sides of the die are 1 through 6, or are 2, 3, or 4. So 1 plus 1 plus 1, 3 out of 6 simplifies to get us 1/2. Okay, the probability of not rolling a 5. So the way that we would write this is P parentheses not 5, probability of not rolling a 5. And this is, whenever you do the probability of not rolling a 5, you take 1 and subtract the probability of rolling a 5. Okay, so 1, remember, means 100%. So what we're doing is we're taking 100%, subtracting what we don't want to have happen. And that would be rolling a 5. So anytime we have to find the opposite of something happening, we do 1 minus what that is. So 1 minus stays the same. The probability that we roll a 5 is still 1 out of 6. And so 1 minus 1 out of 6, we can change that to 6 over 6 minus 1 over 6. And that gets us 5 over 6. And if you think about it, think about how many sides don't have a 5 on them. 1, 2, 3, 4, and 6. 5 out of 6 of those sides don't have a 5. And so that's why it would be 5 over 6. Another way we could think about that is we're finding the probability of 1, a 2, a 3, a 4, or a 6. Well, you add those probabilities up, you get 5 out of 6. Okay, so that's the probability of not rolling a 5. Okay, the probability of rolling an 8. Well, it's a 6-sided die, so the probability of rolling an 8 is impossible. That is never going to happen. And so that would be 0. Okay, and then the probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6. Well, if you roll a 6-sided die, how many times you're going to land on 1 through 6? Every single time. And so that would be 6 out of 6 or 1. There is a 100% chance, it is certain, not likely, it is certain that you land on 1 through 6 if you roll a 6-sided die. Okay, so that is finding the probability of rolling a die. Okay, for this next one, I want you all, if you want, to pause the video and find those probabilities that are listed there. Okay, so the first thing that we need to do when we have these number of marbles is we need to figure out what is the total number of marbles. And so add those up, because remember, the probability ratio is the number of favorable outcomes over the number of total outcomes. We need to know what the number of total outcomes is. And so we're reaching in and pulling out a marble. We need to figure out how many total marbles there are. 5 plus 8 plus 7 would be 20. So there are 20 total marbles. Every probability is going to be out of 20. So the probability of picking a blue marble, there are 5 blue marbles out of 20. And so 5 out of 20, that simplifies to get us 1/4. The probability of picking a blue marble will be 1/4. Probability of selecting a green marble, green would be 7 out of 20. And we cannot simplify 7 out of 20. So that would be the probability. Probability of not selecting a green marble. Okay, we could think of this 2 different ways. Okay, the first way is to think of 1 minus the probability of a green. That's the first way. So let's find that first. So the 1 minus stays the same. The probability of selecting green would be 7 out of 20. And so 1 minus 7/20, 20 over 20 minus 7/20, we get 13 over 20. The other way we could think about it is if we are not getting a green marble, what color would we be selecting? We would be either selecting a blue marble, find the probability of selecting a blue marble, or plus the probability of selecting a red marble. Well, we want to add those two together. Blue was 5 out of 20, plus red was 8 out of 20, and 5 out of 8 would give us 13 out of 20. So there is a 13 out of 20 chance that we do not select a green marble, and we can find that by doing 1 minus the probability of selecting a green marble, or we add the 2 colors that we could get, red and blue. All right, and then finally, the probability of not selecting blue plus the probability of selecting blue. Well, you think about it, everything is either blue or it's not blue. And so if we did the math just to check, the probability of selecting blue is 5 out of 20, plus the probability of not selecting blue would be everything else, red plus green. 8 plus 7 would be 15 out of 20. 5 plus 15 gets us 20 out of 20. And 20 out of 20 simplifies to 1. So there's a 100% chance that we either select a blue marble or we don't select a blue marble. Okay, so that's finding the probability of a simple event. The last question I want us to look at is this one. You are tossing a coin 50 times. The first 49 times land on heads. So what's the probability of the coin landing on tails for the 50th toss? So the 50th time you toss it, what are the chances that you land on tails? Take a second, come up with this probability. Okay, every time that I flip a coin, it does not matter what happened the previous time. When I am flipping a coin, I just care about what's happening that time. And so every time I flip a coin, what are the chances that it lands on tails? Every single time I flip, it's a half or 50%. Does not matter what happened the previous 49 times. Every time that I flip a coin, I've got a 50-50 chance, right? That's 50% heads, 50% tails. And so don't let that trick you of what's happened the previous 49 times. It's always a 50% chance. And so make sure you don't get tricked by questions like that. Make sure that you remember probability, you only care about what is happening on that toss, on that time, right? So that is the first set of probability of simple events. So go ahead and work on these practice problems.